Here we have an equilateral triangle ABC. What do we know about such a triangle? All three sides are equal, all three angles are equal, and each angle is equal to 60 degrees. What we need to find is the area of this triangle. What is the area of any equilateral triangle? It is root 3 by 4 into a square, where a is the measure of one of its sides. For example, we will deal with BC and we will try to find what is the measure of this side BC. Now, what else is given? Inside this triangle, we have three circles. Three circles, all of them having radius 1 unit. Now, what else is similar between these three circles? You will notice that each one of them touches two sides of the triangle. For example, if you consider this triangle, it touches this side and this side. Similarly, if you look at this triangle here, it touches this side and this side. So, in other words, what we have here is a symmetrical figure. So, instead of breaking our head with all the three of them, let us just concentrate on any one circle, and whatever result we get here, that will apply for the other two also. So, let us concentrate on this one. We are just concentrating on this one circle with its center at the point O, and let the point of contact with this side BC, let it be P, and the point of contact with this side of the triangle, let it be Q. Now, if you join these two sides, you will notice that triangle BOP and triangle BOQ are congruent. They are congruent using SSS or SAS or RHS in many ways. Why is that? If you look at this point B, then BP and BQ are tangents from the same external point. Then what do we know? The tangents from the same external point are equal in measure. And what about OQ and OP? Both of them are the radii, which means radii of the same circle will always be equal to one another. And the third one is going to be the common side. So you can use the SSS congruency, or you can use the RHS congruency also. Why is that? If you see, you have a tangent here, you have a radius here. At the point of contact, the radius and the tangent are perpendicular to one another. So you can use the RHS also. Long story short, these two are congruent, which means what? All the corresponding angles are equal. That means this angle here and this angle here are equal. This angle and this angle are equal, but P and Q are equal. We already know that. Here you have a 90 degrees. Here also radius and tangent, you will have a 90 degrees. This we already know. And this we have found out that these two angles are same. But then we started with an equilateral triangle. Each of the angles were 60. So when you cut this into two equal parts, each one will be a 30. So you are going to get a 30 here, a 90 here. Then if you consider the triangle BOP, what does its angles look like? A 30 here, a 90 here, which means the third side is going to be the third angle is going to be 60. Or in other words, triangle BOP is a special triangle. Its angles are 30, 60, 90, which means the ratio of the opposite sides is going to be 1 is to root 3 is to 2. Now remember, this is the ratio, this is not the side. What we are saying is that for some x, if the side opposite to 30 is x, the side opposite to 30 is going to be root 3x, and the side opposite to 90, the hypotenuse, is going to be 2x. Now what is BP? BP is the side opposite to this 60 degrees. But what information do we have? Each of these circles is of unit radius, which means it is of radius 1 units. Opposite to 30, you have a 1 unit, which means opposite to 60, you will have what? you will have root 3 units. So this much is going to be root 3 units. Now let us put the second circle in its place. Let its center be at the point N. Let the point of contact with the circle be, say, R and S. Again, you will have a 90 degrees here, because at the point of contact, the radius and the tangent will be perpendicular to each other. Again, you will have a 30 degrees. All of the same steps you can continue here by CPCT. The corresponding parts of congruent triangles. This 60 degrees is going to be split into half, which means you are going to have a 30 degrees here, a 60 degrees here. Opposite to 30, a 1 unit. Then opposite to 60, a root 3 unit. Here also you are going to get a root 3. Now this part, join this ON. What sort of a figure is this PONR going to be? You see here OP and NR are both equal. Why is that? All the three circles were equal. They have equal radius. Each one of them was 1 unit. When we say 1 unit, it can be 1 centimeter, 1 kilometer, whatever. But 1 unit. This was 1 unit and this was 1 unit. There. And what else do we know about these two line segments, OP and NR? What else do we know? Here we had a right angle, because the radius and the tangent, they make right angles with each other. Here you had a right angle. Here also we had a right angle, because again radius and tangent. Then that means what? OP is parallel to NR. Now this result we have got for 90 degrees, but remember this result is true for any angle. If you have two lines, say one is OP and another one is NR, I will take the same two lines here. If they make the same angle with a third line, this angle also makes a 30 degrees and this also makes a 30 degrees, then remember it means that the two lines are parallel, because they have got equal corresponding angles. Now what do we call a quadrilateral whose one pair of sides are equal and parallel? What do we call such a figure? It is called a parallelogram. So PONR is a parallelogram, which means opposite sides are equal. But what is ON? You have a 1 unit here and you have a 1 unit here, because this is the sum of the two radii. So totally you have 2 units here. It is a parallelogram, which means opposite sides are equal. So here also you have 2 units. So BC is a root 3 plus 2 plus another root 3. So this is how our equation looks like, and the final answer that we are looking for. So there, this is the answer that we are looking for. That is all for today. Assalamu alaikum.